Would you like to access Fusion 360 model and lifecycle data without having to install Fusion 360? Then Fusion Data API is for you. Hi, I'm Adam Nagy, a Forge developer advocate at Autodesk, and that's the topic I'm going to cover in this presentation that is part of our Forge Data Days series. I will make some forward-looking statements as well in this presentation. That's why we have here the usual safe harbor statement that you can read in your own time later on. The Fusion Data API provides manufacturing design data in the cloud with granular and easy access. Currently, it only enables read access to data, but we are working on letting you modify existing data and also extend it with your own custom data. We want to provide a cloud-based source of truth for all valuable product design and manufacturing data. It will not matter whether the data is authored by an Autodesk application or a third-party application. No need for desktop authoring applications like Fusion 360 or Autodesk Inventor to access it. In another presentation, you might have seen how our partner Bomber is using this API to synchronize data between multiple systems and can even use it to provide notifications to users when a new milestone version of a model is available. Fusion Data is one part of the global cloud information model we are working on. This API focuses on the manufacturing side of things and provides the following: access to model properties like part number and description. Here I'm not talking about the new model properties API that is available in Autodesk Construction Cloud. This is about properties coming from the Fusion 360 model. The API lets you traverse the hierarchy of the model, including both internal and external subcomponents. Access lifecycle properties that are in sync with what's available inside Fusion 360 Manage, our lifecycle product. Thumbnails even for internal components, unlike with the model derivative service where you could only get thumbnails for a file, not for internal components. Eventing, in other words, getting notified about certain events like creation of a milestone version. We call it eventing to differentiate it from the well-known Forge webhooks API that you might already be familiar with. Beyond all the above, it also exposes all the data management API functionality related to getting the list of hubs, projects, folders, files, and versions a given user has access to. So you could create an app only using Fusion Data API that lets a user navigate all the files they have access to on Forge and then provide model and lifecycle information about the selected model. All the properties and hierarchy information are stored in parallel with the geometric information. So far shown as option A. If you wanted to get information out of the model, then you had to get it translated first, then you had access to model properties and hierarchy information. But now, with Fusion Data, shown as option B, you can access such data as soon as the file is saved and the new version is created, without having to wait for any translation to take place. Here you can see how we can request, for example, the description property of a model, which is just simply description. Then go into Fusion 360 to modify that property. So we are going to just simply change it from description to new description. Once that's done, then we are going to be saving it and thereby creating a new version. And as soon as that happened, we have access to the latest value of the description property without having to wait for any translation or further processing to take place. Internally, we have a REST API that interacts directly with the graph database where all the data is stored. However, the structure is a bit complex, and you would need to understand all the relationships between the nodes in order to use that API. So we decided to create a wrapper on top of that API using GraphQL. This can drastically reduce the number of requests you need to send to us. Instead of you having to call our REST endpoints multiple times, all those calls can be done internally by the GraphQL layer. So what is this GraphQL technology that we are using? It is becoming a popular way to expose and let users query data in a nice, structured way. Don't let the name mislead you. This technology is not specific to graph databases. Its name simply means that the data is made accessible through a graph-like query language. The data could be coming from anywhere, from a REST API, some internal structure, database, or anything else. It was created by Facebook back in 2012 and released to the public in 2015, so it's quite mature by now. And so many companies have been using it already, including the creator Facebook, Meta, of course, Twitter, PayPal, Pinterest, etc. And now Autodesk is using it as well for Fusion Data API, our first ever public GraphQL API. Just like REST APIs, GraphQL as well provides CRUD access. In other words, the ability to create, read, update, and delete elements. In GraphQL, all read operations are queries, and everything else that modifies the data, the create, update, and delete operations, are all mutations. Its website has a great documentation, nice graphics to help explain the concepts, tutorials, support for multiple programming languages. And the banner just says it all. This technology enables you to describe the data you want to expose, let users make queries on that data, and provide them with exactly what they ask for. GraphQL enabled us to present the data in a way that's using the same terminology that Fusion 360 users are already familiar with, exposing components, occurrences, versions, part number, descriptions, etc. You can see how nicely the hierarchy information provided by our GraphQL query lines up with the structure shown in the model palette inside Fusion 360. If you were to compare GraphQL to a REST API, then you'll find that GraphQL has the following benefits. A single query can retrieve results from multiple REST endpoints, which means less calls. You can also add multiple queries to a single API call, which also means less calls. You will get back just the data that you are interested in, no unnecessary data that you would have to traverse to find what you need. Let's see these in details. I'm going to use the Forge Data Management API for comparison. As an example, if you wanted to get the names of all the projects you have access to using our REST APIs, you would have to first request the list of hubs you have access to, then for each hub request the list of projects it contains. As you can see in GraphQL, I can simply request all this in a single query, asking for all the hubs, their names and IDs, and then for each hub getting the name for each project they contain. With REST, you have to send a request multiple times in order to get back results for multiple different items. In GraphQL, I can combine two completely separate queries, one looking for the hub named Fusion Data and requesting all the project names inside it, and a separate one looking for a hub named My Hub and requesting all the project names inside that as well. With REST, you will get back all the data that is exposed through a given REST endpoint, whether you want it or not. With GraphQL, you can specify what you are interested in, and only that will be returned. In this example, you can see that we just want the names of the hubs we have access to. But instead, in case of REST, we get lots of unnecessary data for each hub. Type of the hub, its schema, links, etc. With GraphQL, we get just what we asked for, the name of each hub, nothing else. Currently, only the eventing part, where we create webhooks to get notified about milestone creation, supports all the CRUD operations. And we only have read-only access to the rest of the objects, but we are planning to expose ability to modify other data as well. You'll find the documentation of the Fusion Data API at the link below, which provides you with a nice overview of the capabilities, tutorials, samples, and also a list of all the objects that are exposed. The source code of the samples can be found inside this GitHub repo. Since there is a single endpoint where you can send your GraphQL requests, therefore the samples are fairly similar. Mainly the GraphQL queries are different. One of the samples also has a live version that lets you log in using your Autodesk credentials and play with the Fusion Data API. It's using a library called GraphiQL that makes it really easy to provide a very nice, intuitive graphical user interface for your GraphQL APIs that lets your users interact with your API and quickly get familiar with all the data it exposes. Many web services, including GitHub itself, are using this component to provide a kind of playground for their customers. GraphQL lets you type in your queries, then run them, then get back the results. And while typing your queries, it also offers IntelliSense, listing the options available for you. It also has a documentation explorer on the right, which will list all the possible queries and mutations you can use. As you may remember, in order to get back information, you need to run a query. If you want to modify something, then you need to use a mutation. When you see the list of available queries, you'll also find, of course, the one we just used at the beginning, simply called hubs, that returns all the hubs the logged in user has access to. But we could also start with other queries like projects that returns a given project based on the hub and project ID, or item which can return a specific file or folder based on its ID, etc. As you keep clicking on the various types, you'll quickly discover the whole object model exposed through the Fusion Data API, with all the various types available and the properties they have. Apart from the Fusion Data Explorer sample, you can also check out the other 3 samples showing specific workflows. Let's have a look at one of that gets the thumbnail of a given model. All 3 samples have a similar structure. The index.js is the starting point where you have to provide your Forge app's client ID and client secret, plus the location of the model you want to work with. In other words, the name of the hub and the project where the model resides, plus the name of the model itself. Currently, the samples assume that the model is inside the root folder of the project. However, it would be quite straightforward to modify the code in order to work with a model that is inside a subfolder of a project. This specific sample you see on the screen now shows how you can get the thumbnail for a given Fusion model. You can just open up Fusion 360 or the Fusion team website in order to find the name of the hub, project, and the model that you want to work with, and then update the values of the variables in the index.js file accordingly. The OAuth.js file is using the usual Forge authentication APIs that all Forge developers are already familiar with. In this case, we need to use a 3-legged authentication because that's what the data management API requires when accessing models on the Fusion team. And finally, app.js is the file that contains all the functionality related to the Fusion Data API. You can see the single endpoint that you need to use to access all the GraphQL functionality. In order to get the thumbnail for our model, we just have to run this single query. First, we query for all the hubs and filter the result to the hub with the given name we previously provided. That should return a single hub as a result. Then we query for all the projects inside that hub and filter the results to the one with the name we also provided previously. Then we query for all the files and components that are available in the root folder of that project and filter that for the one with the name we provided. And since the thumbnail might not have been generated for the given component already, therefore we have to check its status. We have to keep sending this query to get an update of the thumbnail status. This process is similar to how you translate files using the model derivative API or get properties out of an already translated model with it. Once the status is success, we can use the provided URL to download the thumbnail. As pointed out in the prerequisites, make sure that the Node.js version on your system is at least 16 before trying to run the samples. You can simply run node-v in the terminal to check the Node.js version currently being used on your system. Before you can run the sample, you need to use npm i in order to install all the required components in the node modules folder. Then use npm start to run the sample. So to recap the whole process, once you downloaded the sample, all you need to do is set the values of the highlighted variables in the index.js file. Then you can run npm i to get all the necessary libraries installed into the node modules folder. Then can start the app using npm start. You'll have to open the given URL in the browser so that you can log in using your Autodesk account. So we are just navigating to our sample, typing in the email address. It's requesting it again, so just typing it again. I just have to copy paste my password from my password manager. And once that's done, the program will continue execution and send the GraphQL query to Fusion Data API. So as soon as the thumbnail is available, its location will be printed to the console that you can open it. And here is the thumbnail of our model. You can run the other two samples exactly the same way. One sample shows how you can get the full hierarchy of a given model, and the other shows how you can subscribe to the milestone created event in order to get notified when someone creates a new milestone version of your model. We also have a great sample utility web app available online that you can log into and start testing the API with. It's using the same GraphiQL component as the first sample, but has many other features as well. On the left side, it provides a tree control that lets you access any of the models that you have access to. This app as well is using the Fusion Data API under the hood to populate the tree control. Apart from being able to run any GraphQL queries you want, it also suggests queries for you depending on what object you select in the tree control. For example, if you select a hub, then it shows you how you could query for all the projects in it, and the contents of the root folder of those projects. If you select a project, then it shows you how you could query for the contents of the root folder of that project. If you select a model, then it shows you how you could query the component version of the model, get properties like part number and description, and also get a list of the other components this model is referencing, and the properties of those components as well. You can of course run all these queries by clicking on the play button in the user interface and get the results back in the panel on the right side. It also has a tab called Demo App that shows the hierarchy inside the selected model using a graph visualization library. You can simply double-click on a node, and if it has subcomponents, those will appear and you can drag them around. There is another tab which will use the well-known Forge viewer to display the selected model. Then there is the Component Table tab, which shows the same hierarchy that was presented on the Demo App tab as a graph, but this time organized into a table and also including component properties and thumbnails. So basically providing a BOM information for the model. And last but not least, there is the Query History tab that not only lists the queries you ran in the query editor, but those as well that the app used to populate the tree control, the name, the username, the icon, and the Forge viewer. It might be quite useful to have a look at those as well to see what API requests the app is making in the background. The Fusion Data API provides an eventing system which is basically like webhooks, but this system is separate from the Forge webhooks that you may be familiar with already. Currently, it only supports the milestone created event. As the name suggests, this allows you to get notified when a new version of a model is saved as a milestone in Fusion 360. A couple of the things we are currently thinking of providing later on. Expose more properties that customer asks for, like volume and bounding box. Provide an extra function that not only returns the components that a model is directly referencing, but the full hierarchy of the model, however many levels it may have. As previously mentioned, we are also planning to enable write capabilities on the data, and even let you create your own data that you could attach to components. Finally, just a quick recap of the main resources that will help you get started with the Fusion Data API. There is the online documentation, of course, the GitHub repo with the samples, the 2 online utilities that let you play with the API, and the link providing info about how you can contact us if you need any help. I hope you found this presentation useful and it convinced you to give this API a try. Bye for now.